Hello, everyone. Welcome to Unit 3, Lesson 2. We're going to be continuing our discussion of geometric sequences here, and this is going to be a follow-up to our lesson from Friday, where we saw some application type problems, and we also saw the use of the geometric sequence uh, being geared towards making predictions about future terms or determining if a value is part of the sequence. So I'm going to recap that lesson from Friday in today's video and also kind of show you, what we're expecting on MyOpenMath as well to make sure that you are prepared for that. All right. So when we look at the goals for today, again, we want to be able to identify the multiplier of a geometric sequence, whether it's just straight given to us, or if we have to determine what that multiplier is from a list of numbers, or if we have to pull it out of a real life scenario. Okay. We also want to identify the zero term of the geometric sequence. Same thing from all three of those different contexts, whether we have to get it from a list of numbers or an application. But we need those two things so that we can write the equation of our geometric sequence. All right. Now, once we have the equation, we want to be able to predict a future term. That's kind of the whole point of writing an equation for something and modeling a situation is that we use it to make predictions. All right. So if we have an accurate model of a situation, we would like to know what's going to happen in the future. All right. And then also we want to make sure that we can determine if a value is part of the sequence. And we're going to use a table to do that. All right, so let's get right to it. We've got a geometric sequence here, so we can see the first three terms, 6, 18, and 54. And remember that a geometric sequence means there's a constant multiplier that's being used to generate the numbers. So this is going to be multiplying by something, and we need to figure out what it is. So sometimes you just have to take a minute and stare at the numbers and see if you can think of the pattern that is happening to go from one term to the next. Are we adding, multiplying, subtracting? What is going on here? And then predict the next two terms. All right. So if we look at this one closely, going from 6 to 18, we are multiplying by 3 here. All right, so 6 times 3 is 18, and then if I go from 18 to 54, we're multiplying by 3 again. So we see that pattern of multiplying by 3. So to get to our next term, we're going to do the same thing. We're going to multiply by 3 one more time. So I'm going to pull up my calculator here, and let's go ahead and multiply by 3. And you can use any calculator to do this. You don't have to use the calculator that I have here on the screen. So I'm going to do 54 times 3, and we get 162. So go ahead and jot that number down. We got 162, and then we're going to multiply by 3 one more time here to get that fifth term that they want. So times 3 again, and we get 486 as that fifth term. Okay, so just identifying the pattern is always step one with these types of problems. And once you've identified the pattern, you've actually identified the multiplier, right? Once we figured out that we were multiplying by 3, we figured out the b value, so b is going to be 3. And then we got to go find the zero term. So remember, when you're given a list of numbers, they always start you off with term 1, right? So this is 1, 2, 3, 4, and 5, right? Term number 1, 2, 3, 4, 5. Well, term 0 is going to come right here. Okay, it would be the hypothetical term that comes before the 6. This is where the 0 term would be. So to go backwards, right? So moving forwards, we multiply by 3. So to go backwards, we would divide by 3, right? So if I'm going this direction, we would divide by 3. So 6 divided by 3 gives me 2. All right, so that would be my 0 term. All right, so now we know the multiplier, we know the 0 term, and we want to write our equation. And just a recap from, or not a recap, but a recall from our first lesson, we learned that geometric sequences always take on an equation of the form a times b to the n power. All right, so a being the 0 term, so that's 2. And then b being the multiplier, so that's 3. So we got 2 times 3. And then n tells us how many times we want to repeat that multiplication. So we throw an n on there. And if I ever wanted to know a specific term number, I can just plug in that term number, and that would tell me how many times I'm going to multiply by 3. All right, so let's give it a try. Right, so this is kind of the new piece right here, right? This is where we stopped in lesson 1, and now we're kind of taking it a bit further because we want to make a prediction using our equation. So we want to predict what term 17 will be. And the thing to remember here is that the term number will be the input of the function. So essentially they're telling us that n is 17. So we want to find t of 17. So we're going to set that up using our equation. We're going to say t of 17, right? And this means we're plugging a 17 in for the n value. So I'm going to say 2 times 3, and then instead of n here, I'm going to put a 17 on the 3. So it's 2 times 3 raised to the 17th power. And it seems kind of crazy, but easily doable with our calculator. All right, so I'd go here, I'd say 2 times 3, and then this button, if you're using the TI-84, this is how you raise. Otherwise, it's Shift 6 on your keyboard. If you're using another calculator and you have to type it in with your keyboard, you would hit Shift 6 and it will move you up into the exponent. So I'm going to plug a 17 into the exponent and hit Enter, and there's our number. So we've got 2582. 2582, and then we have 80326, big number. Then we go 3 if you want to add in the commas, right? So 258,280,326. It's a big number, and it's important to understand, you know, when we deal with geometric sequences, these are very similar to exponential functions, and those functions grow really fast, okay? So you should expect to get large numbers when you're doing problems like this, right? So that's how we make a prediction. We can say, okay, well, 17 terms later, this is the number that we're going to get. Well, let's go the other direction, all right? So the question is, will this number, right, 42,896, will that ever be a value in our sequence, all right? And if so, when, right? So we would look at our sequence, right? We would generate all of our terms and look for this number to appear somewhere in the sequence, all right? Now remember, this number is a term value, so this is an output, okay? This is an output, not an input, so we're going to be looking here in the output part of our table. Remember, n represents the inputs, so the t of n's are the outputs, all right? And we already have the first 5 terms of our sequence here. So remember, it went 2, then 6, then 18, right? Then 54, and I'm going to have to go back up and take a look at this thing. We got 162 and 486. Okay, and then we can continue our sequence from there and look to see if this number ever pops up in our sequence, right? And the way that I'm going to do that, I'm going to do that with Desmos. Desmos is a great tool for this, makes it really easy. So let me show you how this thing looks on Desmos. All right, so when we get to Desmos, you're going to be here on this screen. You just want to type in your equation just as you built it. So we're going to say T of n equals 2 times 3 raised to the n power. Remember, to get that n there, I just did a Shift 6. So that should put you up in the exponent. And then if you hit this little gear wheel here, it says Edit List, and you'll notice some things pop up here, and it says Convert to Table. So we're just going to click that, and you'll see that a table starts here. And then to quickly generate our table, you can just add in the term numbers, right? So I'm going to put a 3 here, and you'll see it automatically generates the term value for term 3. I'm going to do the same thing for 4, and then 5, and then 5 again, 6, 7, 8, 9, 10, right? So I think that might be enough. But let's use this to fill in our table on our notes here, right? So we had stopped at 5, so we got 1, 4, 5, 8, and then 4, 3, 7, 4. All right, so now I've got my table filled in. Like I said, I just grabbed those values from Desmos. And again, the question is whether or not this number pops up anywhere in our sequence. And if we look at our table, all right, this is 42,896. If I go all the way here to term 10, you notice that we have 39,366. And then when I go to the next term number 11, we see 118,098. So that's way bigger than the 42,896. So I go from 39,000 to 118,000. So it seems that I would skip over this number. So this number is not going to appear in our sequence anywhere. All right, this is not a value of our sequence. Otherwise, we would see it, right, this exact number somewhere in the table. Okay, so we would say no. 42,896 does not appear in our sequence. So pretty easy stuff, right? So predicting and then looking for specific terms in our sequence using the tools that we have. All right. So let's move on. This was also part of Unit 3, Lesson 2. We were kind of looking at different scenarios. I think we looked at pennies and zombies, and then um, some of the practice problems that we're going to see today have some other scenarios that'll be fun to explore. But the pennies example was a good one from Desmos, so I'm going to recap that one from Friday's lesson in case you missed it. So let's say we start a collection of pennies, and you start with 1 penny. Oops. I should fix that table there, right? So that should be 1 penny. And then every day you double the number of pennies that you have, all right? So these problems are going to be pretty similar. You're going to see a word like this where it says either double or triple or something of that nature to kind of tell you how things are growing. And that's really the key piece of information that you need to grab out of the scenario, right? They're going to tell you what you start with, and they're going to tell you how you grow. All right, so if we're starting with 1 penny and then we double, right? If I double 1 penny, we're going to get 2 pennies. And then if I double again, right? So if I double 2, the double of 2 is 4. And if I double 4, I get 8. And if I double 8, I get 16. Right, so forth and so on. So once you understand how it's growing, it's really easy to generate the table that represents this scenario. So we'll do one more time here. 16 times 2 is 32, right? So we have the first 5 terms of our sequence. We have inputs and outputs defined, right? So every day we're doing this, and we are counting the number of pennies that we have at any point in the sequence. All right. Now, if you look at this closely, you're going to notice the pattern, right? So once you have a list of numbers, it's easy to identify the multiplier and the 0 term, okay? So let's go. We've got 1 penny, 2 pennies. So it looks like we're multiplying by 2. So we're going to say b equals 2. And then the 0 term, this one's going to be kind of tricky for this scenario. And this is actually a good example of why the 0 term is kind of not really part of the sequence, right? So if I'm looking at my list of numbers, I have 1, 2, 4, 8, dot, 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 right? And this would continue on. And this is term 1, 2, 3, 4, right? So to go backwards in my sequence to get to term 0, we would divide by 2, right? Because moving forward means that we multiply by 2. So if I take 1 and divide by 2, we get 0.5 or 1/2, which is ridiculous because you can't have half a penny, right? But it is the 0 term that we need, okay? This is what we need for our equation. So we're going to say the 0 term equals 0.5. This is essentially where our equation is starting, not necessarily the scenario, okay? So now if I want to write my equation, we use that same format from the first page, right? So we're going to say our 0 term, 0.5, put that in parentheses, times our multiplier, which is 2, and then we raise to the n power. And there's our equation, okay? So now that we have our equation, like I said, we like to make predictions, right? So I'd like to know how many pennies we're going to have on day 15, okay? So recalling what we just talked about in our previous example, the day number, right, is the same thing as the term number, right? So we're saying that's an input. 15 is an input, which means I would take the 15 and I would plug it in for n. So I'm going to say t of 15 equals 0.5 times 2 raised to the 15th power. So all I did was I plugged the 15 in for the n part of the equation, and then I would go to my calculator and type this in and see what I get. So I'm going to say t of 15 equals, I'm going to grab my calculator here. So we've got 0.5 times 2 raised to the 15th power. There it is. So we would have 16,384 pennies. Okay. Then we would say that in English, right? Because we want to make sure if someone's asking us this, we don't want to just say 16,300. We want to give a little bit of context when we explain things. So we're going to say on day 15, we would have 16,384 pennies. It's a lot of pennies. All right, guys, that's it for today's help video. Hopefully this helps you out. Give those practice problems in My Open Math a try, and make sure you ask questions in the Zoom chat. Have a great day.